For this lesson, we're going to be talking about systems again. And we've already dealt with systems of linear equations where we had two linear functions and we would try to figure out what the solution was. Now we're going to include quadratics with linear functions. And it's actually a lot like what we just dealt with in terms of solving quadratics, but there's a couple steps beforehand you have to take before you can do anything. So first and foremost, let's discuss graphically. What did it mean when we had a solution to a system of linear equations? On the graph, what did that look like? On the graph, we knew that there was an intersection point. I mean, that was the big deal. Intersection point. The two graphs intersect. And wherever they intersected, that would be your solution. Because again, those two graphs, those two functions shared an x and a y value at that coordinate. Now, for the second one, algebraically, what does it mean? And this is the one that's going to basically be the big push for this section right now. Again, algebraically, what did that mean? When we had two linear functions that were in a system, what did it mean when they intersected algebraically? And if you guys don't remember, it's when the two equations were equal. Because again, at that point, they have the same x and the same y value. So if they're equal, if we set them equal algebraically and solve that equation, that means we have our intersection point, the x and the y value. So that's going to be the big foundation for this lesson right here. So let's just jump into it. It says solve the following system of equations. And we have, as you can see, for these two examples, we have a quadratic and a linear for both. Now, graphically, I'm going to show you what the first one looks like because I want you guys to be able to see what we're trying to do here. Now, if we pull up Desmos, I already have them graphed, you can see that a quadratic function and linear function, they cross. And they cross at two coordinates. Those two coordinates are going to be my solutions. Now, if we take a look, the first coordinate is 1, 0. So that means I'm going to have a solution at 1, 0. The second coordinate is negative 3, 4. So I'm going to have a solution at negative 3, 4. So again, graphically, that's what this looks like. Where do these two functions intersect? And again, since it's a quadratic, it should intersect twice. Sometimes it'll intersect once. Sometimes it won't intersect at all. But our main focus for this chapter, for Math 1, is they're going to have two intersection points. So let's get down to work. Solve the following system of equations algebraically. Again, when these two systems have a solution, that means they're equal. So if they're equal, I'm going to take my quadratic and I'm going to set it equal to my linear equation. So I have x squared plus x minus 2 equals negative x plus 1. Because again, I want to figure out where these two equations are equal. Where are they the same? Where do they have the same x and where do they have the same y coordinate? So, as you guys know from last part of the chapter, if we have a quadratic, how do we solve quadratics? How do we determine the x value of a quadratic? I'm not talking about the vertex at all, so we're not going to be doing negative b over 2a. It's the other x value that we had to find. So, we know if we have quadratics, you have to set it equal to 0. So I have to move negative x plus 1 over to the other side. So I'm going to add x minus 1 plus x minus 1. Because again, the x is negative and the 1 is positive. So, if I add those over, I have x squared plus 2x minus 3 equals 0. Now, if I'm looking at this, I have a quadratic. We've gone through two real solution methods of solving quadratics, factoring and quadratic formula. Now, when I made these problems, guys, I tried to make it all factorable because that's all you're going to be able to see on the Math 1 test is factoring quadratics. So I kept these to factorable quadratics. So if I look at x squared plus 2x minus 3, I'm looking for a number, or two numbers, that multiply to negative 3, but add to 2. So if I have my x, well, the only way to multiply to 3 is 3 and 1. And if I want a negative 3 and a positive 2, that means the 3 has to be positive and the 1 has to be negative. That means x minus 1 equals 0, x plus 3 equals 0, x must equal 1, x must equal negative And again, those were the two x values that we got from our graph. If we take a look, our two x values are negative 3, 4, and, well, negative 1, 0. So we have our x values. Now we need to get our y values. So if we're looking at this, just go back and think about, okay, if I have my x, how do I get my y value? And typically the answer we have is, well, plug it in. So I need to plug in my x values and then calculate my y values. And I have to do this twice because I have two x values. I have 1 and negative 3. Now, my word of advice, you can pick either equation. Pick the equation that's easier to work with. So which one do you think is easier to work with? The quadratic or the linear? I'm going to go with linear because, again, it's less terms. We're not squaring anything. It should be a piece of cake. So I'm going to plug in 1 and negative 3. So over here, I'm going to have y equals negative x is going to turn into negative 1 plus 1. Y equals 0. That means my x value, my coordinate, is 1, 0. And that's what this showed in the graph. Now I'm going to do the same for the next one. Y equals, my x equals negative 3. So if x equals negative 3, y equals, negative 3. Again, I'm plugging in for the negative x. Negative 3 would be 3 plus 1. Well, y equals 4. So my coordinate is negative 3, 4. And again, that's what we saw graphically on that chart, on that grid. So, guys, that's the concept. Again, it's everything we've done already. We've already solved quadratic equations. But from here, it's just one extra step beforehand. Take the linear equation, set it equal, move everything over, because again, if we're solving quadratics, we need it to equal 0. Let's try the second one. So again, I have two equations. One's quadratic, one is linear. Now again, if I want to know when these two things are equal, I'm going to set them equal. So I'm going to say x squared minus 11x minus 36 has to equal negative 12x plus 36. Okay? So, well, I know if I'm going to solve this thing, the right-hand side has to be 0. So to make that 0, I have to add 12x and I have to subtract 36. Add 12x and subtract 36. Now, when I add 12x, I get 1x. When I subtract 36, I get negative 72. Because again, negative 36 minus 36 is negative 72. Now, I told you these would be factorable. We need two numbers that multiply to negative 72, but add to positive 1. So if we think negative 72, the most prominent one, and the one that we're going to use, is 9 and 8. 9 times 8 is 72, and we can make it a positive 1 by making the 9 positive and the 8 negative. So 9 times negative 8 is negative 72. 9 plus negative 8 is positive 1. If we set these equal to 0, I don't need the parentheses. I am going to say x plus 9 equals 0. X minus 8 equals 0. Well, x must be negative 9 and x must be 8. So, again, same concept. We have to plug these back in to figure out what our y values are. Because again, remember, solutions to a system of equations is not just an x coordinate. It's going to be an x and a y coordinate because it's a point on the graph. So, I'm going to take my first one. I'm going to take x equals negative 9. Y equals negative 12 times negative 9 plus 36. Well, if we do negative 12 times negative 9, we get 108. Positive 108. So if I look at that, well, 108 plus 36, that's 144. Now, it would have taken us a while to see that graphically because look how large that y value is. We didn't do anything wrong, it's a large y value. So my coordinate is negative 9 and 144. Let's go ahead and do the second one. If x is 8, I'm going to have, well, y equals negative 12 times 8 plus 36. Well, we know that if I do negative 12 times 8, I'm going to get 96. Negative 96 plus 36. And that is going to get me, well, it should get me negative 60. Should get me negative 60. So, I have my two coordinates. My second coordinate is going to be 8, negative 60. And again, there's nothing wrong with these y values being so large. But again, as you can see, graphically, it would have been a pain to see everything. We would have had to put them in Desmos, zoom out a lot, and then try to figure out where these two things cross. So, now, there's one thing I want to do with you guys to show you a very rare example of when something happens. And like I said, I highly doubt you're going to see this on your test. But I just want to make sure if you do see it, you're not taken aback by it. And actually, I'm going to show you graphically. I'm not going to show you guys how to do this algebraically. We can, but it's the answer you're going to get. You're going to realize I made a mistake, that something's wrong. So I'm going to bring up Desmos. We're going to have 2x squared plus 3. So if I bring up Desmos and I get rid of both of my graphs I already had, I'm going to have y equals 2x squared plus 3. Now, if I bring up my second, I have y equals x plus 2. So my second graph will be y equals x plus 2. Now, look what happens. When you have these two equations, they don't cross. So, do you think there's a solution for this system? Again, remember, a solution is when two equations cross. There is no solution here. There's nothing. They don't cross once. That means there is no solution for this system of equations. Again, we can tell this graphically because they're not crossing. Algebraically, we're going to end up getting imaginary numbers. And I'm going to show you real quick what that looks like. But again, this is just to make you aware that this could happen. So, no, I don't want tablet mode. If I go back, if I set these two things equal, 2x squared plus 3 equals x plus 2. I'm going to subtract x. Let me get a different color so you can see that. I'm going to subtract x and subtract 2 minus x minus 2. So 2x squared minus x plus 1. Okay. Right? Did I do it? I think I did, right? Yeah, I did it right. We're good. So, again, I'm not going to try to multiply and do stuff like that because there's no way to multiply. So first and foremost, there's no way to multiply to a positive 2 and add to a negative 1. There is no way to do that. So let me break out the quadratic formula to show you what happens. X equals, well, negative b is negative 1, so it's 1 plus or minus. And we're going to pay attention to the square root specifically. I'm going to have negative 1 squared minus 4 times 2 times 1 all over 2 times 2. So I have x equals 1 plus or minus the square root of, well, this is 1 minus 8. 1 minus 8 is, well, negative 7. Now, let me ask you this, and this is as far as I'm going with this problem. Is there a number, and I'm looking at the square root right now, is there a number that multiplies by itself to get a negative 7? First off, can you multiply anything by itself to get a negative? Think about it. If we multiply a positive by a positive, that's a positive. If we multiply a negative by a negative, that's a positive. The only way to multiply a negative or to get a product that's negative is by multiplying opposite signs. But that defeats the purpose of multiplying by itself because it has to be the same. So there is no way to multiply, there is no way in the real number system to multiply to negative 7 by using one number and itself. That's why this is in the imaginary set of solutions. So there are things called imaginary numbers. We don't get to in Math 1, but just know that this happens. You probably won't see it on the EOG or the EOC, but again, just be aware that it's out there. Okay? Now, you guys already know how to do the following. So I want you guys to take some time, practice 1 and 2. Again, one thing I want you to notice though is that these equations are slightly different. Notice in the first one, that's not y equals, that's y minus 30. Every time that we dealt with problems in the beginning, notice, they were y equals y equals, y equals y equals. Down here, they aren't. So as you guys go through this, make sure they're y equals. So if I get you started in the first one, how do I make that first equation y equals? Well, I can just add 30. So I really have y equals 12x plus 30. Once you have y equals on both, you can then set them equal to each other and solve your quadratic. I'm not going to go through these on the video, guys. You're more than capable of doing these on your own. And the one question I'm very curious about is comparing characteristics, the last one. And I'm going to leave this one to you as well, because back in chapter 2 when we dealt with linear functions, we had to find y-intercepts. So this is a good review if you're trying to review linear functions. How did we make a linear function? We took coordinates, we had to find slope, but again, there's other stuff too. So I want you guys to go through this last one as well. Try to do the best that you can. I do expect you guys to be able to get an answer. I will check over your work on Monday, and we'll go from there. Otherwise, thanks for watching. Hopefully you guys understood it. I'll see you later.